Now that we know how to determine what the transformations of a parabola are from the vertex form of the equation, we can take a look at how we can use those transformations to graph what the parabola looks like by hand. Okay, so I'm going to just go over again how we determine what the transformations are from the vertex form of the equation. So let's say I have y equals negative 1/2 x minus 4 squared, subtract 3. Okay, let's say this is my equation. So from this, I'm going just left to right to kind of see what each piece means. So this negative here is telling me the direction of opening. Okay, so again, if it's negative, it's opening down. If it's positive, it's opening up. So in this case, it's opening down. Okay, and we can also call that a reflection over or in the x-axis. Okay, so that's what that piece is telling me there. My a value is 1/2. Okay, I don't need to pay attention to the fact that it's negative because I already addressed that. So this means there is a vertical stretch by a factor of 1/2. This piece here is my h value, and we need to remember, like I said, your x, y's, we're flipping the sign. Okay, so this looks like -4, but we're going to flip it to be +4. Okay, so h is +4, which tells us that this is a horizontal shift 4 units right. And then the last number here, this is my k value is -3. So this tells me there is a vertical shift 3 units down. Okay, and if you need further explanation about how I can tell all those things, then make sure you've watched the previous video on determining transformations from vertex form. So based on this vertex form of the equation, we are going to see how we can graph the parabola on a Cartesian plane. So I'm going to show you how to do this. I'm going to rewrite my equation here just so we can see it. So we'll have y equals -1/2 x minus 4 squared, subtract 3. So when I'm graphing this, the first thing I'm going to do is I'm going to write the coordinates of my base function, my parent function, y equals x squared. As you practice this more, you'll kind of have these memorized, but I will also give them to you when I'm asking you to transform. So this is my x, this is my y, and when I'm graphing this, I'm always going to start from -2, then go -1, 0, 1, 2. Okay, and these are going to be just my base coordinates. Okay, so I'm going to fill this in here. So each of these, I'm just squaring my x value to get the y value. So this is 4, 1, 0, 1, 4. Okay, so those are the base coordinates of the parent function, and I'm going to transform them to the coordinates of my transformed function, okay, of this formula. So I guess actually, sorry, I don't really need to write that again, just so that I have space here to show what I'm doing. So what I'm going to do is I am going to just duplicate this table of values. Oops. Sorry, I don't know what happened there. I'm going to copy this table of values and then just replace the numbers in it. Okay, so I'm going to bring this over here, keep it in line, and I'm just going to erase what my actual values here are. So what is going to happen is from my equation, I can tell what my vertex is. Okay, so we know from looking at this, I said in the previous part up here where all the pink is written, that I have a horizontal shift 4 units right and a vertical shift 3 units down. Okay, and because this is in vertex form, we know that the vertex has to be HK, right? So I'm going to just kind of divide this here. So vertex is always going to be HK. So in this case, my vertex is positive 4, right? We flip the sign on my H value, negative 3. That's my vertex. So what I'm going to do is I'm looking at my parent function and seeing where is the vertex in this equation, which is here. It's always going to be 0, 0 from the parent function. And I am going to transform that vertex into the vertex that I know is in my transform function. Okay, so 4, negative 3. I know that that's the vertex because I'm given the equation in vertex form. So I can say that the point 0, 0 on my graph is going to transform into 4, negative 3. Then what I'm going to do here is I'm saying, okay, from this table of values, 0, what did I do to get to 4? What did I add or subtract? So obviously to get from 0 to 4, I'm going to add 4. Okay, so I'm going to put that in my table of values. It's going to be x plus 4. And I'm doing the same thing with my y value. How did I get from 0 to negative 3? What did I add or subtract? And I would have had to subtract 3. And the last thing to remember here is that what you're going to do is you're going to look at your equation and take your a value, which is negative 1/2, and you're going to put that in front here. Negative 1/2 times y subtract 3 is how we are going to transform the y values. The only reason you don't notice it with the vertex here is because this was 0. If you do negative 1/2 times 0, that's just going to give you 0. Subtract 3 is 3. Okay, so you're looking at what your vertex is based on the equation. Your 0, 0 vertex from the parent function is going to transform to that vertex. And then we can transform the other values based on the transformations that we have applied here. Okay, so we're going to add 4 to all the x values, and all the y values we're going to multiply by negative 1/2 and then subtract 3. Okay, so if I take a look at this, I'm going to show this in a different color. I'll show it in blue, or maybe actually I'll show it in purple so it's not the same as that. So my x values, I'm adding 4 to all of them. Okay, so I'm going to do negative 2 plus 4. That's going to give me positive 2. Then I'm doing, actually I'm going to show this over here, one sec. So I'm going to go negative 2 plus 4. Negative 1 plus 4 gives me 3. 0 plus 4 gives me 4, which I already have written there. 1 plus 4 gives me 5. And 2 plus 4 gives me 6. Kind of a little quick check that you can do here is that your x values, because in the parent function, they were always going up by 1, right? We had negative 2, negative 1, 0, 1, 2. If we continue, it would be 3, 4. They're always going up by 1. When you transform them, they should still be going up by 1 each time. Okay, so we have 2, 3, 4, 5, 6. It would keep going 7, 8, 9. Okay, so use that as a little check, or what I do is usually I'll find like the first 2 values and then just continue the pattern. Then we are going to transform the y values. Okay, so I'll show this in green here. So I'm multiplying all of my y values by negative 1/2, and then I'm subtracting 3. Okay, so for my first one here, when y is equal to 4, I'm going to do negative 1/2 multiplied by 4. I'm going to show it as 4 over 1 just so we can see how we're multiplying our fraction, and then subtract 3. Okay, so 4 times negative 1/2. On your calculator, you can type it in as 4 times 0.5 if that's easier for you, is negative 2. Okay, so you can think of it also as 4 divided by negative 2 is negative 2. Subtract 3 gives me negative 5. I'm going to do the same thing with my next one. So when y is equal to 1, I'm going to do negative 1/2 times 1, subtract 3. Again, if it's easier for you to think of it as a 0.5, that's fine, because when we graph coordinates, it's a lot easier to think in 0.5 instead of 1/2. So negative 0.5 times 1 subtract 3 gives us negative 3.5. We already transformed the next one here, but if you were to do the same thing, right, you'd have negative 1/2 times 0 is 0, subtract 3 is 3. And then what you might notice here is we don't need to calculate the next one because this y value is 1 again. So the equation, if I were to calculate it, would be the exact same as this, right? Negative 1/2 times 1, subtract 3. So this would be, again, negative 3.5. And then my next y value is also 4. So if I copy this, it would be the same, right? Negative 1/2 times 4, subtract 3. So that value would also be negative 5. Okay, so you start with the vertex. You can calculate what the first 2 points are. And then once you have that, you know that it has to be symmetrical around the vertex. So whatever this y value is the same as what this one is. Okay, and then whatever this y value is the same as what this one is. Okay, and then we have our table of values, so we can just plot them. Okay, so doing this is a lot easier than going through and calculating like x equals 0, 1, 2, 3, because this gives us a good snapshot of what the parabola looks like because we're taking the base parent function, right, that's centered around the vertex, and transforming it to this that's centered around the vertex as well. Okay, depending on if you took the course before and you're retaking it right now, you may have seen mapping notation, which is another way to transform. However, this way that I'm showing you is, in my opinion, easier to use. You may be introduced to mapping notation next year. However, if you find it easier, if you've already been taught that way, that's fine. You can use that mapping notation as well, and you'll still get the same values. I just find this method a lot more straightforward, and it's less like memorizing of a formula to have to use, okay? So let's look at another example. We are going to state the transformations of this function, and then we are going to graph. So if I take a look left to right, I'm seeing what's happening here. So this is a negative a value here. So this is going to be opening down. I have 2 as my a value. So this is going to be a vertical stretch by a factor of 2. My h value, I'm recalling that x, y's, so this is not negative 3, this is positive 3. So this is going to be a horizontal shift 3 units right. And then my k value is telling me that this is a vertical shift 6 units up. Okay, so that's kind of like the correct terminology for how you're going to describe the transformations. Don't just say stretch by 2. You need to clarify that it's a vertical stretch by a factor of 2. It's fine if you just put v stretch like that. I'm just doing that for saving space. And then don't just say moves right, moves up. You need to say it's a horizontal shift and then how many units left or right, and a vertical shift and how many units up or down. Okay, so then we want to graph this. So again, I'm going to start with my parent function, x, y, and this is y equals x squared. So I'm going to use the same coordinates that I showed in the previous example. I'm always going to start with those same ones because these are symmetrical around the vertex. Okay, and then I am going to be transforming those. So I'm going to just copy this over here and then just replace my values as I go. Okay, so looking at my equation, I can tell what my vertex is. Okay, so again, I know that the vertex is given by hk. So in this case, my vertex is positive 3, right? Your x lies, so flip the sign, positive 6. So when I'm looking at my table of values, my vertex to begin with was 0, 0. And I'm going to transform that to the vertex that I'm given from the equation. So I'm transforming that to 3, 6. Okay, and then within my table of values, I'm going to take a look and see how did I get from 0 to 3? I added 3. How did I get from 0 to 6? I added 6. And then if I take a look at my a value over here is -2, I'm going to put that here in front. -2 times y plus 6. And now I can go through and transform all of my values. Okay, so starting with my x values, I'm going to go over to the left here. So I'm adding 3 to all of them. So -2 plus 3 is going to give me +1. -1 plus 3 is going to give me +2. Again, I know that my pattern needs to be going up by 1 each time, so you can keep doing the math and check, or you can say, okay, I know it's going to go 1, 2, 3, the next one should be 4, the next one should be 5, and you can check it too, right? You can do 0 plus 3 gives me 3, 1 plus 3 gives me 4, 2 plus 3 gives me 5. Okay, so it's nice that you can check that, but you also know that your pattern needs to follow. It's going up by 1, right? So 1, 2, 3, 4, 5. That clearly is going up by 1 each time. Then I'm going to calculate my y values. So starting with y equals 4, I'm going to do -2 multiplied by 4 and then add 6. Okay, so -2 times 4 is -8 plus 6 gives me -2. Then when y is equal to 1, I'm going to do -2 times 1 plus 6. Okay, so -2 times 1 is -2, plus 6 is +4. And then you can calculate the other two, or like I said, we know based on symmetry, 3, 6 is my vertex, so this value needs to be 4. This one needs to be -2. Okay, so you don't need to calculate them again because it'll be the exact same calculation as before. Okay, so now I have my transformed coordinates, which are these, and I can plot them on my graph. Okay, so I'm going to do this in blue over here. So my first point is 1, -2, which is here. Then I have 2, 4, which is here. 3, 6 is here. 4, 4 is here. And 5, -2 is here. And then if I were to connect that, it's going to be like this. Oh, 1 second. You can see doing it by hand. My curve is quite messy. There we go. I'm going to use the iPad to straighten this out for me. Oops. Look at my points. Close enough. Okay, and then extend on either side. Okay, so this, the blue line, is my transformed curve of y equals -2 x minus 3 squared plus 6. And if I wanted to, this isn't necessary, but if I were to compare it to my original graph, this is where my vertex would be, and then I would have points here, here. Okay, and this would look like this if I graph it. And just adjust this a little bit. Oops. Okay, so this is approximately what my parent graph would look like. This would be my y equals x squared. Okay, so you can see all those transformations that have happened. So it's opening down, or in other words, if we took this graph, it's being flipped over the x-axis, so it would be like this. Then it has a vertical stretch by a factor of 2. So kind of what you can picture happening is if you were to pinch, like if this were to flip, and then you pinch the vertex and pull up, I kind of have told students in the past to picture like a hair elastic almost. So if you're holding a hair elastic and then you pull up in the middle of it, it gets skinnier. Okay, so that's what the vertical stretch means that's happening there. then it's moving 3 units to the right, so 1, 2, 3 over, and then it's going 6 units up, so 1, 2, 3, 4, 5, 6, and that's what the transformed version looks like. Okay, however, you can't use that to do the graph. Okay, so don't, like, I know I just showed that I'm moving over 3 up 6, but don't do that to graph. You need to do the table of values here, show the transformed one, and then plot it. And you don't need to graph the base one on here. I'm just showing you what it looks like compared to the parent function and then the transformed one. Okay, but that is how you use the vertex form of an equation to state the transformations and then to transform your coordinates to be able to graph it.